So let's get cracking. Welcome, everybody. My name is Asaf Anolik. I'm a board member of the Tel Aviv University Trust here in the UK. And I'm really excited about the talk today. We're hosting a phenomenal talk by a guest who visited us in the past in London. And we've received phenomenal feedback from the audiences seeing this talk. This webinar is broadcast as part of the 73rd Independence Day celebration that the embassy in the UK, Israeli embassy in the UK, have arranged a series of events. And I'm really, really excited about this topic because I think at the forefront of research today, when we have advanced technologies such as machine learning, artificial intelligence, and with our own kind of, the human science, which is neuroscience. We just had Elon Musk a couple of months ago released how neuroscience is advancing. And on the cross section of these two disciplines, there's a phenomenal, interesting works being done. And I'm really excited to host today Dr. Goren. Welcome.
Welcome. Hello. Hi, Asaf.
Hey, thank you very much for joining. So I deliberately would like you to introduce yourself and the line of work that you do, and just ask the audience. There is a Q&A panel on Zoom. Please, if you do have any questions, type in there, and we'll discuss on those. Goran, over to you.
Excellent. So, welcome everybody, and I'm super excited to be here. I'll introduce myself a little bit, and then I'll start talking about our work, and me and Asaf will also discuss stuff, answer questions. So first, some things about myself. I've been 20 years a student in university. I have 6 degrees, triple-double. I have 2 undergraduate, 2 masters, and 2 PhDs. So I have a bachelor, a master's, and a PhD in quantum physics, which I'm not going to talk about. But I did write a book about, we invented a new quantum superhero, and it's a book intended to explain quantum physics to everybody. I'm really into explaining my work to everyone who wants to listen. So this is everything about quantum physics that I'm not going to talk about. But I did do a bachelor in medical science and a master's in business administration. And my second PhD was in computational neuroscience, and I'm going to talk about some of the work there, where I studied curiosity. So after finishing my PhDs, I moved to MIT, to the Media Lab, where I did my postdoc. And 6 years ago, I came back home to Tel Aviv University and opened my curiosity lab. And I'm going to share with you some of the stuff I've been doing since. So I also have 4 children, teaching certificates, and I'm teaching at schools, and I'm all into education, and we're going to talk a lot about all of this stuff. Since you're talking about curiosity, I love questions. So please feel free to ask anything about everything, and we'll try to answer them during the talk. And if not, then maybe in the end, and if not, then maybe after the end. We'll see. So why curiosity? Why actually study curiosity? So curiosity is super important for lots of things, but this is something super interesting for me. So here you can see a very simple graph. You have curiosity here and achievement here on the y-axis. And as you can see, there's a socioeconomic status. Everybody knows that high socioeconomic status, they succeed more, they have these privileges, and it's very well known. But what you can see here is that curiosity actually closes the gap. Curious children achieve the same achievement no matter what socioeconomic status they're in, as opposed to non-curious children who have the highest gap. So as you can see from here, curiosity can actually close the socioeconomic status gap and can actually has a huge influence on academic achievement and later in life. So this is one way of thinking of why study curiosity. It's so important in so many aspects of life. But for me, I had this inspiration. So this is one of my children, and you can hear my wife. So as a parent, you see your child standing for the first time, and you're super excited. I'm a genius child. She stood up so early. It's very cool. But as a scientist, you have to ask why. There's no reason for the child to stand up. I mean, even if she crawls until the age of 20, you'll give her love and give her everything. You'll be worried, but she'll still get everything she needs. So why is she standing up? And then I suddenly realized maybe she's tired of shoes and feet, and she stood up. She suddenly discovered there's a whole new world out there, and she's very excited about it. So this is another video which I really like, not because it's my child, not only because it's my child, because you can see that this baby is exploring the world. She's touching this toy, and she's very happy about it. So there is this link between I'm doing something, I'm learning something about the environment, and I'm happy about it. I'm getting some reward. I'm happy about it. So in my lab, we're trying to understand this, formulate it in mathematical and artificial intelligence question, and then create this. So this is George, one of the robots in my lab, and in the sake of Curious George. And we want to make a robot learn about the environment, be curious about it, and be happy when it's learning something new. So you're going to see a lot of robots in my lab, but actually I'm interested in people. So I'm using robots to actually try to understand people better. So one of my PhDs is in neuroscience. So the brain is an amazing thing and very mysterious, but we actually know quite a bit about it. So there's this machine called fMRI. It's a very cold and noisy machine. You put people inside and you ask them to do something, and you see which areas of the brain work when they do stuff. So in this amazing study, they put people in an fMRI machine, and they gave them questions that the people were curious about and questions that they were not curious about, and then they gave them the answer. And they looked what areas of the brain light up when you get information that you're really interested in. And there are a lot of pixels here and a lot of numbers, a lot of letters, but in that we actually know a little bit about the brain. And all of these things are part of what's called the reward network. The reward network works when you actually eat chocolate. You have this dopamine substance in your brain that when you're happy and you learn stuff, and it's secreted when you are happy and eat chocolate. What they discovered is when you get information that you're really curious about, the same system works. So from the point of view of the brain, getting information is equivalent to eating chocolate. It's the same substance in the brain, it's the same neural mechanism, which is very cool. So this is something about the brain. There are more recent research that shows that when you're in a curious state, actually the brain is activated and you're more susceptible to learning. You remember more, you remember more things, you remember more deeply when you're in this curious state, when you're excited and you want to learn. So now we know a little bit about the brain. So I'm a scientist. So if you study something, you have to define it. So there are many definitions of curiosity. This is my definition. It's an intrinsic drive to learn as much as possible and the accompanying behavior. So it's an intrinsic drive. It comes from within. You cannot give a curiosity pill. You can obviously destroy curiosity. It's called the educational system. And that's a joke I'm allowed to do because I'm also a teacher. But you cannot, everybody's curious. Everybody has this intrinsic curiosity drive. And to learn as much as possible means for the curious person, for every answer, there's a new question. You can't just ask a question, give an answer, and say, okay, that's enough for me. You always want to learn more and more, and you actually use what you learned in order to learn more. You scaffold the learning by what you already learned. And the accompanying behavior means that you cannot be a passive learner, a passively curious person, because you always have to ask questions. You can't say, I'm curious, and then do nothing. You have to ask questions, tinker, do stuff in order to explore the environment and learn as much as possible. So according to my definition, yes.
Can I jump in with the first question though? About the definition, and about how you said, regardless of social state, social classes, people are curious. Is curiosity by definition, is it evolving? Is it being developing still? Because I remember myself as a child, when I was curious about something, I had to go and find the actual volume, the right volume in the encyclopedia, the book, to answer my question. And when I see my two kids today, they just ask the ambient and teach themselves. And there's a smart speaker somewhere in the house that just gives them the answer. Is there any is that definition holds true? Is it evolving over time?
Yeah, so it's a great question. So the point here is that the drive to learn stays the same. It does not evolve. We always want to learn. We always want to explore. And now what changes is the information, how we get that information. So maybe the behavior itself is different. So you look for encyclopedias, I played Scrabble and learned some other stuff, and now you ask Google and you just get information. But it's the same behavior. It's not the same behavior. It's a behavior whose goal is to actually learn more. So the behavior may change with the generations, but it's the same intrinsic drive. If someone wants to learn, it still needs to act in order to learn. So once we tinkered with some stuff, and now we build stuff with Arduino and Maker stuff, and you have a lot of more options, but the intrinsic drive is the same. We're still humans. We still want to learn, and now the question is, how do we get information? And as I'll show more in the talk, is what's the environment to enable you to be curious, because we're not always behaving curiously. We always want to learn, but we're not always asking questions. And I'll show some studies to show why is that so. So it's a great question. So once you have this verbal definition, we can start working on artificial intelligence. So artificial intelligence is big thing. There's a lot of misunderstanding what is artificial intelligence, what is machine learning, and here we're actually using a model that captures everything here. So again, because the verbal definition is about learning, you have to have some learner, something that learns about the environment. And here we're using a lot of things from the machine learning. I'm going to drop names because it's fun. We're doing deep learning, and we're doing Bayesian inferences and neural networks. I'm doing a lot of algorithms that learn about the environment, and I'm going to show some examples. But the most important thing about this learner is that it can quantify how much it learns. And this is something very interesting that can only happen when you actually program something. It's very hard to quantify how much a person learns, like to actually give a number. But here there are actually numbers that says how much this computer learned something from the new examples, from new experiences it had, from new data. You can actually quantify how much it learns. And it's very important in the curiosity scheme. But the other thing about curiosity is about the behavior. It's not about the learning. It's what do you do in order to get that information. And here we're using something called reinforcement learning. Everybody knows what reinforcement learning. If you have a dog, you want to teach the dog something, it does a lot of stuff. When it brings the newspaper that you want, you give it a reward, it's reinforcement, and you reinforce that behavior. And there's an algorithm in machine learning that's called reinforcement learning, how you teach a robot to walk. It does a lot of things. And when it's actually succeeding in walking, you give it a big number, and it reinforces all the weights and all the numbers there, so it can learn how to walk, what it should do in order to actually walk. So you have this algorithm here that governs the behavior, how you learn how to behave to reach a goal, to maximize your reward. And here we have the learning. And the curiosity thing, which is something very unique, is that the reward is intrinsic. You don't give it food. You actually, the reward is proportional to how much you learn. So here we try to learn something. The more you learn, the more reward you get. You get dopamine in our brain and a big number in the computer, and you change the behavior in order to learn more. And I'll give an example. If you give a remote with a lot of buttons to a toddler, to an infant, what does it do? It puts it in its mouth, but nothing interesting is happening. And accidentally, it presses the red button. And every time you press the red button, something happens. So it pressed the red button, it was a behavior. It learned something about the environment, it discovered something new, it got reward. So it reinforced the let's press red buttons behavior. And suddenly you see toddlers pressing buttons all the time because they learn that every time they press the button, something interesting is happening. So they learn how to explore. And this is the concept of curiosity. They explore the environment because they know it gives them a lot of information. So once you have this definition, so this is what's called the curiosity equation. Information equal reward. The more information you get, the more reward you get, and you change your behavior based on this reward, based on this equation. And if you have equation, you can program things, preferably in Python, because that's the coolest language. And once you have programming, you can move to this. These are robots. Hope everybody recognizes these robots. So this robot is a Lego. And I convinced my PhD supervisor to actually buy me Lego for research. So during my PhD, I did science with Lego for like 3 years. It was a lot of fun. So I got 3 papers out of it, so that's okay. They got their ROI, it's good. But I studied with Legos about the brain and about infants. What I was interested in is I wanted to model babies. You know, they get out of the world, they don't know anything about anything, and they learn by themselves because you can't talk to them. They don't understand what you're saying. So they need to learn by themselves. So I asked, what does this robot can learn by itself? So it has motors. It has one motor for an arm, one motor for the camera, and the brain. The brain didn't come with the Lego, it just lied around in my lab. So he put it there, and you have a camera. And the question is, what can it learn? So it can learn correlations between the motors and the sensors and the camera and stuff like that. And I program it to learn whatever it can. Like just learn whatever it can. I don't know what you can learn whatever you can. And one of the cool things it learned is to learn to recognize itself. What does it mean when a robot recognizes itself? It means that if this is the input, an image, the output is 1 on the arm of the robot and 0 everywhere else. So it's 1 and 0, 1 and 0. It learned to recognize itself. How did it do that? It learned the correlation. If I move something and something moves in the camera, then that something is me. So if I move my hand and I see something moving, then that something is me. So it learned by itself to recognize itself, But as I told you, curiosity is not just about learning, it's also about behavior. So it actually learned to look at its own hands and, whoo, cool, that's me. And it's very amazing because there is a developmental stage in infants when they actually reach that stage and they discover their own body and are amazed by it. And that robot, just by the curiosity algorithm, reached that point. And that's really, really cool because I didn't tell it what to learn or how to behave. Everything was learned by itself. So that's really cool. So a curious robot can learn about itself. But a curious robot can also learn about social behavior. So this is a study I did when I was in MIT. It has a dragon bot, which is very cool. It's a robot that looks like a dragon, has a smartphone for a face, and it can make a lot of facial expressions. Happy, yawn, yes, no, sad, shy, a lot of faces. And I just recorded the faces of the people around it. And it got reward the more people looked at it because people give it information. The more you look at it, the more you talk to it. So it got a lot of reward the more people looked at it. So the question is, what should the robot do, right? What is the behavior to learn more from the environment, to make people look at it more? So the question is, you have a lot of behavior here. Yes, yeah, sad, think, a lot of behaviors. And I want you to take like 5 seconds to think which behavior actually will make people look at it more, stay there, not leave it. I'm counting to 5 in my heart. Excellent. So I hope one of you thought that it was, happy face, because that's a wrong answer. And I love wrong answers because that's the only way to learn. If you know all the answers, you don't learn anything. I love wrong answers. But the right answer is sad. The robot was actually extremely sad. And when he did that face, everybody said, oh my God, is it me? Is it okay? The robot is a doorknob. It just, projects faces. It's super stupid. But the people anthropomorphized it and, attributed its feelings to it. And the data actually shows that 30 seconds after it made the sad face, no one left it. Everybody stayed there. But the robot was more than that. It actually learned how to behave, right? It's learning something. So after only 2 hours of interacting with people, it cried more than all the other behaviors. So this robot learned how to cry in order to get attention. Sounds familiar to anybody? So again, it's a very human, childlike behavior, right? And the question is, it's a really stupid robot. It looks at faces, it just makes random faces, and if people look at it, it just, change the probability of what it does. And the question is, how can, 20 lines of code and a stupid robot can behave like a person or like a child, right? And the answer is, it's because it interacted with people. It learned about people. If people gave it attention when it was happy, it will learn to, to make a happy face. But we people give more attention to when children are fighting and crying than when they're behaving very nicely, right? If you have like 2 children playing nicely, your first thought is, I'm going to drink my cup of tea, right? But when are you coming to them? When they're fighting. So they get attention when they're fighting and not when they're behaving nicely. So I obviously do experiments on my children because I can. So I'm projecting all of the things I learn about my children. So now when my children, they're playing nicely, I come to them and say, you're amazing, you're good. I give them a lot of affection and attention. And when they're fighting, I give them less. Because of this study that shows that a really, really simple, curiosity-driven algorithm actually, trying to explain sophisticated psychological, developmental psychology concepts in education and behavior of children.
So Goren, on that point, where reinforcement learning, obviously, and everything, machine learning, artificial intelligence is all driven by the data you feed it, right? And over here, the behavior you feed it. Does this mean that across different cultures and different behaviors, we'll get different curiosity models, and therefore you'll start seeing kind of different types of robots acting differently, and they will have different types of applications?
Yeah, it's an amazing question because in these curiosity-driven robots, the social environment is so important. This is what drives the information. This is how the robot learns to behave. So I'm not sure, for example, there have been studies that showing that children are curious around the world. They're all born curious, no matter the culture, they're all curious. But I do believe that the interaction with the parents and the social environment in later ages, I don't believe in the first or second year in life, there's a big cultural change. But later on, when they're coming to the educational system and stuff like that, then there's a huge change. And if you now start to, like, robots will learn from their environment, they will start to depart and accommodate their cultural differences. But maybe that's okay because you want the robot to fit into the culture it's actually deployed in. So that's actually a very cool idea that if the robot learns how to behave with the cultural norms that you have, it will actually be more acceptable. And you cannot take, a robot that grew up in Japan or learned in Japan from data in Japan and bring it to Israel. I'm not sure how that will work. Or from London to Israel. Again, I'm not sure how that will work. But it's very interesting because we actually have, again, a paper on this, that the social environment is exactly what dictates the behavior that will come out of the curiosity. Because if you give it, if you give it one type of information, type of the behavior that people attend to or behave, it will result in different information. This is something that people don't understand about the new machine learning. I mean, people think that you program a robot to behave. In today's machine learning, you don't program a robot to behave. You program a robot to learn to behave. And then the data drives the behavior, not your programming. And if you put it in different data, then it will be a totally different behavior. So it's the new type of machine learning. And actually, curiosity is one step ahead of that, is that you actually don't even dictate what it learns. It selects what it learns, and it selects how to behave in order to learn this. So there's a whole new field here where you program a very complex algorithm, but you have no idea what will happen in the end. It totally dictates but the interaction with the environment. And it's something very cool and very exciting.
So in such an advanced, forward-looking, cutting-edge research, how do you address, risks such as different biases that we have, which, machine learning is very susceptible, and human nature is very susceptible. How do you kind of mitigate that and do research, as clean as possible?
So the problem here is that there are risks in the concept of suddenly the robot can, in a moment I see a robot with children. Suddenly the robot can do something very weird or something bizarre. So we do limit what we call the action space of the robot. We don't allow it to do something dangerous or against the norms or stuff like that. So we do limit the space in which the robot can behave in. So that is one thing. Biases are actually, in our scenario, even much worse than all the other things, because in different machine learning, you actually collect data from Google Images. So you have images from all over the world. A lot of you can somehow overcome biases. In this robot, this is a robot like a child. So if a child grows up, in China, then it cannot differentiate between Europeans. And if a child grows in Europe, it can differentiate between different Chinese people. And this robot, because I'm trying to model a single child, it will have exactly the same biases. And from my research perspective, that's good, because it means that I'm understanding how humans evolve and how humans learn. And that's what interests me. So actually, that's a good thing. If I can recreate the biases, the exact biases that people have, it means that I'm understanding what's their source and why are they there. And maybe later on, how can we mitigate it both in people and in robots? And that's the goal here. Again, you see a lot of robots. I'm interested in people. I don't want to make the best robots ever. Now I'm actually trying to understand humans by creating robots that behave like the brain behaves and learning from the same things that the children behave. And that's the goal of this research. So moving on, can a robot learn about emotions? So this was one of the craziest studies I did when I was in MIT. So we had children. So we put a robot in kindergarten, and we had a child and a robot playing together in a tablet. They played together an educational app to teach Spanish as a second language. The children learned language. That's good. We're not interested in easy stuff like that. What we're actually interested in, you see this phone here, it actually has a camera with a facial expression detection in real time. So the robot knew whether the child was happy or not, or engaged or not, in real time during the interaction. And what we did here, we actually changed the behavior of the robot to actually maximize the child happiness while learning Spanish as a second language. Now you try to be happy when you're studying Spanish as a second language, it's very hard. So the robot actually changed its behavior, changed its facial expression, its social behavior to maximize the engagement and the happiness of the child. And have the children play with a robot that's what we call affective personalization, that changes behavior for each child, and have them not. And we actually showed that children who played with this robot that accommodated and changed the behavior to maximize the balance actually increase their balance, as opposed to children who are not. And that actually shows that the robot can actually learn about environment, the emotions, because today's, machine learning perception is so good that it can capture, whether you engage, happy, frowning, a lot of stuff. And now we can incorporate that into the learning of the robot, that you can actually make a social robot that will try to make the child happy, but while retaining the educational perspective. So you don't want just the robot, the child to be happy, you also want it to learn. And the balance between them is also very interesting. So this is like a transition into the educational part of the talk. So up until now we talked about algorithms and stuff like that, and now we actually went about and used these social robots to actually see whether we can use this for educational purposes. So if you remember,
so Goren, just a question that we received before we go into the educational piece. And by the way, I just remind people that there is a Q&A box that you are welcome to put in your questions, and we'll discuss it. And first question that we received is the research and the applications on curiosity, is that applicable on humans only, or do you also research animals, or is there any specific animals that are more curious than others?
So
what's your take on that?
So actually, my PhD was on rodents, on mice and rats. So I developed my first curiosity algorithm on mice and rats. I was in a wet lab, but our mice were the happiest mice ever, because in order to be curious, you have to supply all the other drives. So they got as much food as they want, they got their mates, they got everything they wanted, because that's the only way that you can be curious. So our mice were the happiest mice ever. So obviously, well, there aren't a lot of curious cats because they're all dead. Yeah, a lot of mammals are obviously also curious. There are some research that flies are curious and have this stuff. I don't like it, but that's what we have. I don't like insects, not from a personal perspective, not from a research perspective. But yeah, animals are curious all over the animal kingdom. I'm not sure it's the same brain mechanism for all of them, but I'm studying humans and related animals. So for all of these animals, all the mammals, the reward system that rewards novelty and exploration is the same mechanism. So we actually show that mice are curious, and you can actually categorize the curiosity based on my algorithm, and you can have a lot of stuff that is very, very similar that I transfer to humans. So my second PhD was about robots and rodents. There was no people in my PhD. I only moved to people when I was in my postdoc in MIT. But I've done only human sense. Yeah. So that's it. So regarding the question, so I have an anecdote. So I taught at my children's school for 3 years, and I challenged one of my greatest colleagues, Susan Engel, who literally wrote a book on curiosity. You have 45 minutes in class once a week. How do you promote curiosity? I don't care if they learn. I just want to promote curiosity. And one of the things was, which I did for like 2 years, the first 15 minutes was ask me any question that you want. Just ask any question you want about anything. And then I gave them points. So it's 1 point for a well-formulated question, 2 points if I don't know the answer, and 3 points if Google doesn't know the answer. And suddenly I got some really cool questions. So I challenge you in the audience to get 3 points for your question. So now I'm trying to accumulate the points, and if you get to 100 points by the end of the talk, then you get a prize. So try to challenge me and Asaf, who represents Google here, with questions. So we actually moved to education now, a good transition. So if you remember the child who played with the toy in the second slide, so she grew up and went to MIT and started playing with robots. And again, it's a child playing with a robot on a tablet for an education thing. Here they learn how to read. We didn't really care. The research question here was whether curiosity is contagious. Whether if you are near curious people, you are becoming also more curious. So there were studies about curious adults who are near other curious adults. They're more curious. Children of curious parents are more curious. Students of curious teachers are more curious. But no one did a study with 2 children, whether 2 children are curious. But a study with 2 children is very hard. So we threw out 1 child, we put a robot instead. And now the research question was whether a child playing with a curious robot becomes more curious. So we did 2 studies on this. The first one actually showed that they are more curious. So how the children train with a curious robot? We said, I have to learn, let's try new things. and have them play with the same cute robot, but just was not enthusiastic of learning. And we actually showed that children are more curious after the interaction who played with a curious child. And then we moved on and actually made my holy grail, which was a truly curious robot. So the curious actually had the algorithm I talked about before. So it had the algorithm of curiosity. It actually learned with the child. And the more it learned, the more it was happy. And it explained to the child why it's happy, because I'm learning more. So it was actually close the loop of a robot with the algorithm, the curious algorithm, and the social interaction. It actually expressed that algorithm to the children who they played with. And we actually showed the children are more curious when they interact with these kind of robots. And then actually this is the transition to the other part here, where how do you actually measure curiosity? So I went to my study, yeah, probably there's a measure of curiosity, right? There's a measure for everything. Let's do a measure of curiosity. And there was no measure of curiosity. So it was like $1 million question, because I got $1 million to answer that question from several grants. And then I started to develop a lot of curiosity assessment tools. So this one we actually did in the open days in Tel Aviv University. So we got like 500 applicants for the Tel Aviv University, and we just gave them this screen. This screen has all the symbols of the faculty of Tel Aviv University. And we didn't tell them anything about anything, because when you assess curiosity, you're not allowed to give them an external goal. You can't tell them go and learn, because they will try to learn. But if you don't give them any goal, then their curiosity suddenly emerges. And what we did in this study is half of the children, half of the people here had a button that says stop. Just, stop this thing. And half the participants didn't have the stop, and they had for a full 2 minutes of exploration. And what we discovered is that when you have the button stop, most people press it after like 40 seconds. But they learned less. And people who actually explored for longer, they learned more, they remembered more, they just learned more efficiently and better. And the cool thing about this, it has an educational perspective here. When you give an opportunity to run, to escape, boredom, then children will escape it. If a child comes to you and bored, said, you should say, good, be bored. Bored is excellent, because when you give them the space and time to explore, to be bored, to actually try to learn something, then they will learn. And if you give them the fast way out, they will take it. But they will learn less. So it's a very, very cool thing that we discovered here. And then we moved to children, and we developed 4 apps. This is one of them. It's called the Question World, where you can ask different questions. And our research question was, do curious children ask different questions than non-curious children? But again, we wanted to do it quantitatively. So I won't bore you with the details. We developed a network theory algorithm of what is a good question. And we actually discovered that curious children actually ask different types of questions, not more, different types of questions. They're asking questions that lead them to a new information that you cannot get any other way. It is called specific questions that have a really quantitative measure that you can measure, and they ask these really unique questions that give them information that you cannot get any otherwise. And we ran this study with Youth University, Tel Aviv University, and you got this really interesting result that you can actually quantify curiosity, how were they assessed by their teachers, just by this 2 or 3 minute game. So curiosity is very, very complex. So it's not that one game captures curiosity. That's why we developed more tools. And we have more tools for adults that develop that relate to physical curiosity and other stuff.
So Goren, on that point, there's just a question from Ori, age 13. Does the external features of the robot, do they affect in any way on the type of questions that the kids are asking the robots? Does that kind of physical embodiment kind of influence the interaction and the feedback loop that the kid then receives in return?
Yeah, so as you can see, I brought 2 robots to my talk. So I'm actually in my office, and the 2 robots that we ran studies with. And we have one study, I will talk about it in a different context, but to actually compare these 2 robots. So this robot is a commercial robot that costs $10,000. It's amazing. It dances and does stuff and has computer on board and cameras and discover lots of stuff. This is a robot my students built in my lab with 3D printing. It's called, I don't know, it costs like $500. And we did a study that actually taught children some stuff, and we compared these two robots, which are totally different. And what we showed is that the learning, the actual what children learned, actually exactly the same for these two robots. So they prefer this robot because it's more roboty and more cool, but the actual impact on learning and the actual, in the end, what they learned and how much they scored the test, never mind, how much they gained was the same for both robots. So there is a very important thing on the interaction itself and the sociability regarding the embodiment of the robot. But if you actually want to teach, it doesn't really matter in the end.
Okay, that's great. And another question, Sharon from Sweden asks, how do you actually define what a curious child is? You kind of show the graph on, curious children ask different questions. What's the definition of a curious child?
So again, it's an excellent question. It's extremely hard. For that specific study, we actually asked their teachers to rate their curiosity. So it was like an external thing. It's like the teachers had, 20 or 30 students in their class, and they rated each one on like 10 questions, how curious they are there, how many questions do they ask, how are they participating in class, a lot of questions that relate to whether a child is curious or not. So the actual measurement of curious children are it's not what the children talked about themselves, it's how the teachers rate them. And it's very important because in a lot of places now they want to screen for curiosity, right? Both for elite places, for elite programs, and also for jobs. You want your workers to be extremely curious and want to learn and excited. And also in elite programs, also in Israel, you have this IDEA, Odyssea, a lot of really cool stuff in youth university. You want to take the children who are curious, want to learn. So we actually developed this kind of study in the sense of, can we actually try to differentiate between the curious children and non-curious children? And what do they do today when they don't have any measure is they ask the teachers. I mean, that's the gold standard. Just ask the teachers who's more curious in your classroom. And we're trying to actually change that to a more quantitative, model-based, scientifically anchored assessment tool. The problem is that curiosity is not one thing. It's a lot of things. So I showed you only one tool. We're developing 4 different tools, 4 different games, each one changing measuring different aspects of curiosity, question asking, tinkering, exploration, a lot of different stuff in order to get a more comprehensive view. We haven't done that study yet. We're now doing it online and we're going to make it very big. It's a very important way to measure curiosity in a very quantitative way. And the only gold standard today is what the teachers and the parents say. You don't have any other gold standard today. It's very weird. But actually, curiosity is one of the worst studies, least studied topics. For example, you can compare it to creativity, which is also very important. There are tons of tools of assessment of creativity. Like, take these blocks, build something. There are tons of tools of creativity. For curiosity, not so much.
It's amazing. It's amazing because you kind of highlight a gap here. I personally, anecdotally, from my experience, I see how curiosity is so impactful and so meaningful. If you look at the technology advancements today, as much as we think things move fast, probably is the slowest in the rest of our lives because the pace is just accelerating. And our kids would probably work in professions and occupations that don't even exist. They might be like robot psychologists in the future, who know, and things that don't yet exist. So curiosity seems to be that superpower that is so crucial in anything, our kids will have to deal with in the future.
Mm-hmm. And it's amazing that so today, up until again, this curiosity, this quantitative model-based curiosity assessment, it's just new. I mean, there was before I started, there was only one. Before I started, there was only one tool. The only way to assess curiosity today is what we call self-report questionnaire. You get a questionnaire, rate between 1 to 5. How curious are you? That was the only thing right there. So it was validated and everybody used it. But again, I'm a quantum physicist. I have a problem with people rating themselves whether they're curious or not in a job application.
You're both curious and not at the same time.
Yeah, exactly. So again, I'm trying to build this quantitative tool, and also it's not just quantitative; it's model-based in how the brain works and all the concept of what is information, how do you learn, what do you do, and anchor them and then we're trying to validate them in a lot of ways. So this is the things we do, and we really try to do this. So the other way, and this is something, again, it's on the border of two different topics. So we actually try to assess social curiosity with robots, because why not? It's cool. So we have like 4 robots here. And as you can see, the robots are moving like non-verbally. It's pointing, and this one is nodding, and this one is looking away. And the participant here is wearing eye tracker. So there is this friendship matrix between here. He's trying to learn about which robot is a friend of whom. And what we did is we actually solved all the equations. There are a lot of equations behind the scene. And we know what the optimal person should do. We have literally an equation and the behavior, what the optimal person should do. Which robot should it look at? Which gives it the more information? What's the optimal behavior for a curious person? And then we measure what the people did. And then we suddenly have like a distance metric. We can, we can see whether the person's behavior is optimal or not, which is like behaving to gather the more information or not. And actually this robot is also, I like it because that's the experimenter. I don't believe in human experimenters. I know they have biases and stuff. So all my studies are now having a robot experimenter. So it's totally producible and it's saying the same stuff. So this robot actually tells this person what's the experiment about. It's very cool. And what we did in this study is that we put a participant here and we didn't tell it anything. And the robots started to look at one another. And then this robot says, okay, which robot do you think is a friend of whom? So it didn't know even there was a study. Okay, it didn't know what was the task. It didn't know anything. And then we repeated the task several times. Our hypothesis was, when curious people, even when they don't know anything, but they see something happening in front of them, we'll behave better, we'll learn more, we'll do stuff. And we were actually surprised. It was actually the opposite. So what you can see here, it's a different repetition. So we repeated the same experiment 6 times, but for each person. Each person did this 6 times. In the first time, he didn't know what was the task. He just looked at people, looked at the robots, and he didn't know what was the task. And what we did, we asked people, did a lot of questionnaires. Some of them on psychological inflexibility and social anxiety and curiosity. And what you can see here is that initially, the behavior is dictated by the psychological inflexibility and social anxiety. So the behavior is not determined by curiosity. And you can actually see the dynamics here, which is amazing. You see that as the experiment goes on, the social anxiety and psychological inflexibility disappears, and curiosity increases. And this shows dynamically that curiosity, you need to feel safe, you need to be not anxious, you need to be in a place where you understand what's going on before your curiosity can actually manifest itself. And that is super important for education. If you think, for example, like first impressions, if you think, for example, that a teacher goes to the first day of class, and one child asks a lot of questions, the other one doesn't. Then the teacher says, oh, well, that child is, is very curious. And that's just wrong. It's not that this child is curious and this one is not. This one feels more safe and less anxious. Because only when you enable an environment when the children feel safe, not anxious, not afraid of anything, only then will their curiosity be manifest and they can ask the real questions. And now the actual thing about promoting curiosity, as I said in the beginning, you cannot give a curiosity pill. Curiosity comes from within. But what this and other studies show, that you need to create the environment. You need to show the child that being curious here is good. So the robot that actually promoted curiosity, it promotes curiosity by being curious, by role modeling curiosity and showing the child that if you're curious, nothing bad will happen to you. You can explore here. You can try different things. It's okay. I'm doing it and nothing wrong happened to me. So it's just by enabling the environment. And again, all these studies using social robots and these quantitative studies actually show this. And this work is actually one of the first things that actually uses social robots to actually investigate a psychological thing. The study is about psychology, but I'm using robots as a tool. And this is something I'm really trying to promote because I think there's a huge opportunity here, using social robots as a tool for studying psychological things.
So Goren, on that point, you mentioned that it's such a vast multidisciplinary kind of research field, right? You have behavioral, you have psychology, you have computer science, you have robotics. How is kind of
education, yeah, crazy.
And education and kids? and you know, the future of work and the future of, you know, of a lot of other things. How is your lab unique, or how does your lab kind of, you know, collaborate with other faculties in the
Yeah.
university? How do you approach such a vast multidisciplinary
So
research?
yeah, it's a very, very challenging thing. So first of all, I'm taking students not only from my department, I'm industrial engineering department, which actually is a very special department in the sense that they actually learn psychology, computer science, and robotics in my department. That's the only department that actually does all three. But I'm also taking, I had a mathematics student, I have a mechanical engineer student, I have students from education. So I'm bringing a lot of students from all over the disciplines to actually augment me, and I'm doing tons of collaboration. So the assessment collaboration was actually from someone from assessment. The psychology, this collaboration was someone from psychology. So, and I'm going to show another study with someone from linguistics. So I'm just collaborating with all of these people who are expert on their domain, and I'm bringing the social robot and the algorithm to it. And this is the only way. I cannot, although I learned a lot, I actually, all of these things I didn't learn. I didn't learn psychology, I didn't learn computer science, I didn't learn engineering, I didn't learn education. So I'm a curious person, so I'm doing stuff that I don't know anything about now. But I'm collaborating a lot, and it's very hard in the sense that it's so multidisciplinary that the research, your target audience is problematic, right? I mean, computer scientists don't understand what are all these people doing in this study. And then the psychologists say, well, what are these letters and Greek letters that are doing in my paper? So it's very, very hard to try to understand. It's a very hard sell. All of these multidisciplinary studies, but it's not. I think everybody knows that's the future, right? I mean, that's where all the major advances will come when you integrate all of these knowledge that accumulate over the years from all of the disciplines together, and that's the way to go. So I'm
Yeah.
really,
Okay.
really
Great stuff. So just a reminder of the audience, we have 12 minutes left. So please put your questions in the Q&A tab in Zoom. And Alex Levy asks on something kind of previously that you've mentioned, why or how does a large number motivate a robot? I think it's more basic when it comes to reinforcement learning.
Like 30 seconds on reinforcement learning. If you have a robot, you want to teach a robot to go forward, and it can go forward, back, left, or right. It first selects randomly. So let's say it selects forward. You give it a big number, okay? Just a big number because this is what you want. What the number means is that the probability of the next time it should select, the probability to go forward increases and all the other ones decrease. And now it selects again randomly, but with a higher probability of going forward. Let's say it goes backward. You give it a negative number, right? Like a punishment. And then the probability to go backward actually decreases and all the other increases. So even by not telling it to go forward, just give it a reward, and a big number when it does what you want, and a small number when it does what you don't want, you actually change the probabilities and the behaviors, and that's how reinforcement learning works. And what in curiosity is that number is how much you learn, which is very cool. It's something intrinsic to what you're doing, and something very cool. So moving on to education, and now we moved into less curious but more education oriented things. So again, there's this what we call 21st century skills, right? You have this creativity and curiosity and critical thinking, collaboration, communication, growth mindset, a lot of things that we know that older children need. And now we're trying to promote them with social robots. So we showed curiosity, we actually have a paper on growth mindset, and here we're working on collaboration. So as you can see here, these are students in our lab, and they're actually doing a group activity, which is facilitated by this robot. So the robot said, okay, please everybody answer the question on your tablets. And then after that say, you didn't give the same answer. Please, discuss among yourself and reach a consensus. And because we have a lot of very sophisticated perception now, so we know the facial expression and who's speaking and what's going on, the robot can actually use this to facilitate in the optimal way the discussion, to ask the one who's not speaking to speak more. If someone is dominating the conversation, you can ask him very politely to stop talking. It's very important in Israel. It's a very, very important thing. And then we move to children. Again, these are my children, this is my robot. And we started actually studying schools, where the goal here is to actually teach the children how to do group activity by themselves, how to listen to one another, how to give positive feedback to one another. So this robot is, because they don't learn this in school. There's no lesson on how to work together, like really, like by the best pedagogy that research knows. So we're implementing all the research. We're actually taking this robot to a group facilitation course, and we're programming all the course into the robot. And now we're using it to facilitate interaction between children in schools. So this is things we're trying to do. This is actually with the Ministry of Education in Israel, and we had this big study. And this is what we did. Again, one study that I talked about is last study, almost last study, I promise. So this is a robot that actually teaches Hebrew roots, teaching children the Hebrew language, very young children. And this is a collaboration with Dr. Goren from Tel Aviv University, who was linguistic, and actually came up with a new paradigm how to teach Hebrew roots. And she came to me because she said, I can't replicate myself. And I said, hey, I can replicate you. And we just put her in the robot, and we did a study, on 40, 50 children in the youth, in the summer school in Tel Aviv University. And it's crazy. So I don't know if you understand this, but we actually showed that kindergarten children, after like 2 weeks of playing with the robot, reached the level of second graders in Hebrew root extraction, which is crazy. So this is one thing. And the last thing, and again, if you're in Israel, if you don't open a startup, you'll get deported. So we had to open a startup. It's called Curiosity Robotics, and this is part of the research we're doing also. It's teaching toddlers English as a second language using this robot. And we did a study that actually showed that children are, if children and their parents playing with the robot, they have a lot of more social interaction than if they're playing this exact same thing on a tablet. Because today they have only tablets. And what the tablets is, the problem with tablets is that they're attention grabbers. If children playing with tablets, they don't have any attention for anything else. And we showed that with robots, they actually interact more with each other. So to summarize, right? This is time to summarize, Asaf? Excellent.
Yes, we have 7 more minutes.
Excellent. So I'll summarize, and then we have a lot more questions. I'm summarizing the topics of my talk, and then we have a lot more questions. So, so again, as I showed you, the curiosity is something that can be quantified. It can be used to actually learn about people and understand why children behave as they do. But now we're moving to education. It's not only learning, but actually influencing and helping the educational system because it needs some help. So we want to revolutionize education by having social robots, not to teach math and language and stuff like that. It's good, but actually to try to promote 21st century skills. And the social robots have a lot of amazing potential. They can be optimal teaching assistants. We don't want to take the teacher's job. We want teachers in class, but the teachers are swamped. And what we're doing here is actually helping teachers when they need help, right? So for example, you have a big classroom separated into small groups, but you still have one teacher. So my vision is to actually have one social robot per group that facilitates the discussion, that personalized to everything, and you can put all the pedagogy. And then the teacher is free to do what the teacher should do, which is educate and be a role model and be all of the stuff that they could, solve social emotional problems and give their attention to the children that need it the most. And the cool thing about it, I think Asaf said it before, is that integrating social learning and artificial intelligence. Up until now, artificial intelligence, this cold thing with algorithms, you have a lot of algorithms, a lot of data, a lot of stuff, but the social robots put in the social learning, the social interaction into it. And we're social beings. We learn best when we're doing it together. And the social robot is actually enabling this. And of course, you can have all this personalization that you have in all of these algorithms out there. So you can have all the best of AI with social interaction also in the education. You can, as I said, you can adapt to each child's preferred teaching method. So you can learn personally, not only the content, but how you teach each one to maximize engagement and fun. And what I showed you, and there are other studies, not only mine, that showed you can, with the social robot, promote curiosity, creativity, growth mindset, collaboration. You can promote all of this stuff with the best pedagogy, and you can put in the robot. And the robot today are scalable and affordable, and what I like it the most is updatable. Once you have a robot in school, you suddenly have a new activity. You don't need to teach the teachers all these activities. You just, update. You suddenly have all this amazing activity. So in all of these studies that I showed you, we just started. So we started to promote children in small lab-controlled studies, some in schools, but we want to go bigger. We want to see whether it actually can be integrated into the educational system. And we just started to work with the Ministry of Education. but we can, we can do so much more here to promote all of this stuff, to test it in the wild, we're now working a lot with teachers. It's very important to work with teachers to understand what's the relationship between the social robot and the teacher in the classroom. There's a lot of things to do here to make it a real revolution in education. And this is, I don't know if you feel it through the screen, but this is my passion in the last at least 7-10 years, to first understand people, why they learn, how they learn, what motivates them. This is all this curiosity algorithm and understand the brain research that they need to understand what motivates children to learn. How does this work? And then implement it in places where you can promote it. You can promote curiosity, you can promote all these 21st century skill, and to put it to good use, because I don't know about you, but I feel that the educational system could use some help. It's very good, but it's not perfect.
Everything is work in progress, right?
Yeah, exactly. And the question is how we can do it. So I'm now trying to just take it to the next level, actually integrate it and get more information from the schools and try to see where we can actually implement it in school. So again, I have to say thanks to all the people who worked with me and a lot of people who funded me, a lot of foundations from all over the world. And actually, that's now time for questions, right? How am I with time? Yeah, I'm actually.
Fantastic. So last question for me, and again, there will still have some time. If there's any other questions, please put them in the Q&A. But last question for me, I mean, just to recap some of the points you've mentioned, this field has implications across, so many different fields of research, goes across social economy classes, goes across culturals, and you can really demonstrate results in a kindergarten, our kids, that they can achieve second graders kind of, academic levels. So it's really, really profound. So for the parents among us who don't yet have educational robots, any specific takeaways? Because some of the things that we saw today is that we can influence curiosity, we can nurture it even without that technology. Just kind of any practical, tangible tips or takeaways you can offer the audience.
Yeah, I actually have a slide for parents, but I took it out today because I know there are children in the crowd, so I don't want to so so I think the biggest message is to create an enabling environment and role modeling. So there have been so many studies that show that if the parents are curious, then the children will be curious. So I was once asked after another talk, by a grandparent, if my grandchild asked me a question, how should I answer? And I told him, answer as if your boss asked you that question. Take it seriously, answer. Don't dumb it down. They understand whatever and always answer really, like you mean it. And if you don't know the answer, then they get better. I don't know. It's so cool. Let's learn together. And then take him to Google together and learn something new. And always answer and always end up with another type of question. Okay. Oh, we learned that. Oh, I wonder what happens now. We learned what that's if. Wow, what happens if we do this now? And to always stimulate the conversation. But again, the most important thing is to create an enabling environment and role modeling for curiosity. These two things are just crazy. They work like a charm.
Fantastic. Dr. Goren, head of Tel Aviv University Curiosity Lab, thank you very much for your time. It's been a pleasure every time we talk. And again, happy Independence Day for Israel. Thanks for the Israeli Embassy in the UK, for Tel Aviv University, for the audience who asked questions. And yeah, let's keep on learning, right? We're all learning in progress.
Be curious, be curious.
Thank you very much, Goren.
Thank you very much.